In this tutorial, we're going to go over how to create a drawing of the Titan 84L in Fusion 360. Let's first take a look at the Titans of CNC drawing, as this will be our guide to create our own drawing. In our upper left-hand corner, we've got this table here, and this is indicating the external data that was derived from the Machinist Handbook. Next to it, we have our front view. To the right of it, we have a section view, which is also our right-handed view. If you look at our section view here, we have a detailed view, which can be seen in detailed A. In the bottom left-hand corner, we also have an isometric view with its own detailed view, indicating some of our thread geometry here. With that in mind, let's jump into Fusion 360 and create this drawing. I'm over here in Fusion 360 and I already have my part up. Before we start this part, I want to include some construction geometry on this particular part. That way I can reference it on my drawing. I'm going to come over and turn the visibility of sketch number 1 on. I'm going to turn my visibility of my bodies off. That way you can see the construction geometry that I use to revolve the part. I'm going to turn sketch number 1 off and turn my body back on. And I want to create a sketch that is on top of my part here. So I'm going to go to Construct and down to Tangent Plane. I'm going to click on this flat area on the end of my part here. And notice we have this tangent plane show up. Well, I want to make sure that this tangent plane is perfectly parallel to my sketch. So I'm going to turn sketch number 1 back on. And notice right now it's not parallel, it's actually perpendicular. And that's okay. I'm going to turn the visibility of my body off. And in my pop-up window, it's asking for a reference plane. Well, the reference plane I'm going to use is sketch number 1. And notice now it's perfectly parallel to it. And then I'm going to press OK. I'm going to create a new sketch. However, this sketch I'm going to be creating is going to be on my construction plane. So I'm going to turn the visibility of my origin off. I'm going to go P on the keyboard for project. Again, we're clicking on this new construction plane. And the geometry that I'm going to project for this sketch will be this arc, this vertical line, and then also our center line for our part, and then press OK in our pop-up window. I'm going to turn sketch number 1 off, and that will show you the geometry I chose. While we're still in sketch number 4, I'm going to mirror this geometry across. So I'm going to go to Create and down to Mirror. The objects I want to mirror will be our arc and this vertical line. I'm going to select my mirror line as our center line and then press OK. Now that I have this geometry in place, I'm going to finish my sketch. And then I can turn the visibility of my body back on. Notice our sketch is on the outside of our part. This is essential, especially when we're using that section view, that it's on the outside of the part and not on the center. The next thing I need to do is if I look at the front of my nose cone here, and then I look at my view cube, the way that we drew this part, Fusion 360 is recognizing this as my left-handed view, not my front view. So what I'm going to do is I'm actually going to revolve this part around, and I want my sketch to be on the left-handed side. The reason for this is we are going to be creating a right-handed view And then the section arrows are actually going to be pointing to the left-handed side. So it's actually going to take the geometry from the left side of our part. Notice now our view cube here says left, and our sketch will be on the left-hand side of our part. I'm going to come up to my view cube and press on left itself. That way it orients our part correctly, and that way the part is sitting correct inside of Fusion 360. I'm going to right click on the view cube and go down to Set Current View as Front. Notice the orientation of my view cube has changed. This is now indicating that this is the front of our part. Before we move into our drawing workspace, I'm going to save my part. That way it updates our geometry. And then I'm going to change my workspace, upper left-hand corner of our toolbar, and move down to Drawing from Design. In our pop-up window here, it's asking first, do you want everything in this modeling workspace to be a part of your drawing? Yes, we do. We are creating a new drawing here. And then the template that we are going to be using is actually a template that can be found in another video on how to create a title block template. And then press OK. Very first thing that Fusion 360 is going to try to do is land our front view. We're going to come over here and change our style to just visible edges. And then we're going to click on our scale down here, and we are going to change the scale of our part to a 2:1 because the outside diameter of this part is 950,000, which is kind of small. And what we're going to do is we're going to kind of land this view right about here, which will give us some room for our table. We're going to left click there and then press OK. Notice though, when I clicked here, all I'm seeing is the outermost geometry of my part here. So I'm going to double left click on it, and I'm going to go to Tangent Edges and turn full length on. Notice by doing that, now we can see the tip of our nose cone. Our next view that we're going to land is a right-handed view. I'm going to go up to Drawing Views and down to Section View, because this particular view is going to be split in half. I'm going to click on my front view here. I'm going to find the center of my part, and I'm going to left click, dragging my mouse down. Be mindful of that green dashed line. That is a construction line there to help you find the center. And after I left click on the other side, I'm going to press Enter to lock that view into place. And I'm going to drag my mouse over to the right, giving us a right-handed view. And then press OK. On our right view here, we also have a detailed view. We're going to go back to Drawing Views and down to Detail. We're going to click on the right view now, and we're going to kind of click in the center here. Dragging out the circle. And we want our threads to reside inside that circle. And what we're going to do is drag our mouse down and over to the side here, giving us a little bit of space to work with. And then we're going to press OK. Almost done. We're going to land in an isometric view. Drawing Views down to Projected View. This one is going to be referenced off of the front of our part. We're going to click on that. And we're going to drag our mouse down vertically like this. Place that view and then press Enter. We're going to change this view from a wireframe into a shaded part by double left clicking on it. And then in our pop-up window, we're going to select Shaded with Visible Edges. And then close that out. I'm going to move this particular view over to this white space here. To do so, I can't simply click on this and drag it over because this particular view is in alignment to our front view. What we are going to do is go to Modify and then Move. I'm going to click on my view here, and then I'm going to transform it from this location over to this location. And hopefully that works. Nope. If it doesn't want to move like this, the issue that we're having is Fusion 360 is recognizing this as a bottom view, which needs to be perfectly in the center of our front view. What we're going to do is click on this and hit delete. That will delete our view. And what we're going to do is we're going to land a new base view here, drawing views down to base view. And we're going to change the orientation of this to our bottom view. Actually, excuse me, to our top view. Let's take a look at that. No. Yeah, we'll choose our bottom, and then we'll change our scale back to that 2:1 scale, and we're going to select shaded with visible edges. We're going to land this view over in the left-hand corner where we want it to be. The issue is this particular view is upside down, so we're going to go to Modify and down to Rotate. I'm going to click on it and then go to Transform. I'm going to choose a point on here, and then I'm going to rotate my part around. And if you give it a second, this will give you a preview of what the part is going to look like, but be very patient because Fusion 360 seems to work a little slow on this. So I'm going to rotate my part around and then press OK. And now I can move this view up into the area that I want it to be in, like so. And now we're going to take a detailed view of these threads here, drawing views down to detail view. We're going to click right here in the center of our threads. Like so. And then drag our mouse over and then press OK. Now that we've got our geometry and our different views on our sheet, let's zoom into our front view here and give it some diameters. We're going to go D on the keyboard for dimension. The only dimension that this particular one has is the outermost portion of the diameter. So we're going to land that dimension in. One thing I want you to recognize here is our measurements are only being stated to the 10,000ths column. In the bottom center of our workspace, we have our annotation settings. We're going to click on this and choose Display Trailing Zeros. And then we're going to change our linear dimension precision to the thousandths column. Notice by doing this, our dimension has updated. This is very important, especially when it comes to tolerancing. We're going to jump over to our right view now. In our right view, what we need to do is we need to turn on that sketch that we created before we left our modeling workspace. I'm going to come up here to our very first base view. I'm going to hit the down caret next to sketches, and then I'm going to turn the primary visibility of sketches on. And then I'm going to turn my last sketch on. Mine so happens to be sketch number 4. And notice when I did that, I have our construction line that is acting as our center line. And if I zoom in, now I have these lines that are coming off of this arc here on both sides. This is important so we can be able to reference off that geometry. While we're here, we're going to go D on the keyboard. And I'm going to choose those intersection points on both sides, like so, and drag our mouse out. While I'm here also, and still in dimension mode, I'm going to choose this radius here and drag our mouse up. And then we're going to select this big radius on the outside of our part. Lastly, before we go over to our ordinate dimensions, I'm going to give this part a diameter. So I'm going to click on the flat edge here to the flat surface here. And then I'm going to click here, then right click, press OK to get us out of our dimensioning mode. And I'm going to give this an extension line by just dragging our measurement up and off the part. Now that I have our regular dimensions in place, I'm going to add some ordinate dimensions in. So I'm going to go to Dimensions down to Ordinate Dimensions. I'm going to zoom in to the tip of our nose cone here. And I'm going to land my datum location right off that intersection point, because that's the tip of our nose cone. And then I'm going to drag my mouse down, landing in our datum location. Notice our 0 location has the decimal point and 3 trailing zeros. If you double left click on it, you can change its primary precision to read just 0. And then close that out. We're going to go back to Ordinate Dimensions. And now we're going to choose the geometry that makes up the horizontal measurements here. Well, I'm going to kind of zoom in and find the end point of that line. I'm going to click on it. Then I'm going to reference back to my datum location where the extension line is coming off. And if I move my mouse back, you'll see this green line appear. That green line is just basically a construction line, so you can get all your measurements in alignment. Now that we have that dimension set, we're going to go to the back side of this flange. Same thing, I'm aligning my measurements to the previous measurement. We're going to go into our thread relief here. We're going to click this endpoint here. Same thing, we're referencing off so we can get our measurements in alignment. And then lastly, to the end of our part, getting everything in alignment. I'm going to right click and press OK. We do have a chamfer up here that we're going to state. We're going to go and use a text with a leader. We're going to click on this angled line coming off here that makes up our chamfer. And then we're going to type in chamfer 10 thousandths by 45 degrees, and we'll enter the degree symbol in our pop-up window. Notice that that's kind of coming off our page a little bit. What we can do is we can click on this particular view and drag it over just to give us a little bit more room. Notice our statement of our section here is really big. What I'm going to do is I'm going to double left click on this, and I'm going to change the height of my text to something a little bit smaller so it's not so big here. Oops. I'm going to highlight everything and change this to 100 thousandths instead, and then close this out. Once I have that, I can move these words up. And now it's not so predominant. Now that our right-handed view is all dimensioned, we're going to jump down and take a look at our detailed view. I'm going to kind of move our detailed view up a little bit. And then while I'm here, I'm going to change our words here that make up detailed B. I'm going to double left click on them. I'm going to highlight everything. And I'm going to change these to 100 thousandths also. And then close this out. I'm going to move this up a little bit to get it out of our title block. Now that we're here, we're going to add in our dimensions that make up some of our geometry here. We're going to go D on the keyboard. The diameter that we're going to choose is the diameter of our thread relief. We're going to click from one line to the other line and land our measurement in here. And then lastly, we're looking for the overall major diameter of our threads. What we're going to do is zoom in, and we're going to look at the crest of our threads, which is this flat area here. I'm going to click on it, and then go to the crest on the other side. Clicking on it, and dragging our mouse over, like so. Right click and then press OK. After I land these measurements, I'm going to get these measurements off of my part. I'm going to left click on them and then choose that little square in the center, and that will give us the ability to put an extension line in. I'm going to repeat that on this other one. Like so. And now that I have those dimensions in here, I'm going to put in a symbol, and I'm also going to put in the width of these dimensions. I'm going to double click on this one. I'm going to go to the front of the brackets here and add in a diameter symbol. I'm going to go to the end of our brackets, put the X sign in, and this thread relief is going to be 65 thousandths of an inch wide, and then close that out. I'm going to repeat this over here. Front of the brackets, insert our symbol, into the bracket, and then put the length of our threads, and then close that out. Notice that our measurements are all on top of each other now. That's okay, we can always drag them around after the fact. Drag this one over here. Then this one I'm going to actually stack on top, like so. These measurements are getting a little close to my measurements up here in my right view. That's okay, I can click on this particular view here and drag it down a little bit, giving a little bit more breathing room here so those measurements don't get confused. We have a little corner radius here, D on the keyboard. We're going to click on this radius right here, drag our mouse out. Like so. And then we want a statement on this radius. When we create this thread relief here, we want this radius to be no larger than 20 thousandths. So this radius is actually going to be derived from the tool that makes that feature there. So we're going to double left click on this to the end of our bracket. We're going to type in max and then the quantity. So the quantity is how many instances there are here. Lastly, we're going to add in our chamfer because our threads need to be chamfered on the lead in and lead out. We're going to use a text with the leader on this one. We're going to click on this edge, drag our mouse out, type in chamfer 35 thousandths at 45 degrees. And that is typical 2 times. And then we'll close this out. If we don't like how long this is getting for our text here, you can always add a return in by holding down Shift and Enter. And that will kind of break up that box, that text box for you. Now that our detail B is all labeled, we're going to run and take a look at detail C. Same thing, we're going to change the size of our text here by highlighting it, change this to 100 thousandths, and then close out our edit window. Now, this particular detail is really not necessary. This is more or less for beginners. And the reason why it's not necessary on this particular part is for a machinist, they should know what the major, minor, and pitch diameters are. However, the Titans of CNC prints are stating them because this is a curriculum for beginners. So we're just going to add this in as practice. The issue that we have is Fusion 360 does not allow us to snap to the center portion of our flank here, which is the kind of the theoretical center of this slanted line to the slanted line here, which makes up our pitch diameter. So what we're going to have to do is we'll have to create some geometry there. So we're going to go to geometry, down to center line. We're going to choose the crest of our thread and the root of our thread. And this will give us this center line here that will make up our pitch diameter. Now that I have our center line here, I'm going to snap the ends of our center line kind of right up to the top here, and then the bottom of it to the bottom of our part. Now that we have some geometry in place, we're going to add some text with the leader line. We're going to reference off of this flank here, and we're going to get as close as we can to that center line. Unfortunately, Fusion will not allow us to actually anchor off this center line. So we're going to reference off the flank and get it as close as we possibly can and drag our mouse out. And we're going to label this as our pitch diameter and then close that out. And then over here, we're going to repeat that, putting in our major and minor diameters. Major diameter is off the top of our crest. And then lastly, our minor diameter is at the root of our thread. And we'll close that out. Notice that our view is getting really close to our title block. We can always click on this and move it around and get it away from all the other objects. At any time, you can always drag your measurements around and your leader lines around to kind of reorganize your workspace. You want this workspace to be as easily read as possible, and you want to make sure that the person who's going to be reading it understands what you're you're talking about. Lastly, I'm going to move this detail C up here a little bit closer to my part. That way we associate it with this detailed view. That's looking pretty good now. Now we're going to come up to the upper left-hand corner where we left this big blank space here. And we're going to add in a table. This table is going to include all the information from the machinist handbook that directly coincides to the external thread data here. We're going to come up to tables and down to table. In our pop-up window here, we're going to select empty table. We're going to click and anchor our table to the upper left-hand corner, like so. And then we're going to click in one of these cells down here, and we are going to delete how many columns there are because we only need one column. So in our pop-up window, we're going to delete selected columns until we see one column. And then we're going to close this out. I'm going to come over to one of my cells here. I'm going to click in the first one and type in external thread data. This needs to be 3/8/16 unified course. Class 2A. I'm going to close this out. Then if I click on my table here, I can actually drag my table out. So we're looking for something that looks very similar to this. I can actually change the dimensions of my cell here by dragging the cells up a little bit. That way we're not losing a lot of space in here. The next cell below it, we're going to state our major diameter. I'm going to change the height of this to 100 thousandths, and then I'm actually going to bold this up a little bit. I'm going to click in the cell below it. The maximum diameter that this part can be is 373 thousandths and 7/10. And we're going to change the justification to middle left on this one. And then we'll change our height to 100 thousandths. Like so. I'm going to click in the cell below it. The minimum diameter is going to be 364 thousandths 3/10. And again, we're going to change the justification, but we're going to wait to the end and we'll change that all at once. The one right below it will be the middle, which is our mean, is 369 thousandths and 0/10. Close that out. If I go back to my last cell, and if I hit Tab, that will give me another cell or another row to work with. This one we're going to label as our pitch diameter. And we are going to bold this up a little bit. That way it differentiates it. Tab again. This one is going to be our max. Is 333 thousandths 1/10. Tab again. Our minimum is 328 thousandths 7/10. Tab again. Our minor diameter, We're going to bold that up. Tab again. It will have a max of 306 thousandths and a minimum of 288 thousandths and a tenth. Now that we have our table filled out, I'm going to come in and I thought this would have allowed us to select all the data, but it doesn't. So I'm going to change the justification of my text and also my size of my text. The height on this text is going to be 100 thousandths, and we're going to use center or middle left, and then close that out. I'm going to repeat that. 0.1, middle left, on all these. Oops. We're just changing how it looks. And then I'm going to also change the dimensions here to 100 thousandths on our bolded text here. I am going to leave the justification centered on those. And then I'm also going to bold up our external thread data sheet here. I'm going to bold that up. I'm going to click on our table. I'm going to drag this down just a tad. Giving that first cell a little bit more room. All right, this is a good opportunity to double check your print. Make sure that everything that you typed in here is accurate. Lastly, we're going to come down to our title block and we're going to update our title block. I'm going to double left click on the lines that make up the title block. And I'm going to click in the attribute there where it says material. Our material is 6061 T6 aluminum. And then I'm going to jump over to our revision block, click in revision and type A, and then press OK. This is a good opportunity. You can move some stuff around the way that you would like to in your drawing. But other than that, this concludes our tutorial on how to create the Titan 84L drawing in Fusion